Today we're going to start chapter 9. We're going to cover half of section 1's notes, and then I'll finish up the notes for tomorrow. So today we're going to learn the Pythagorean Theorem. Now, you probably have learned or have seen the Pythagorean Theorem before in either your pre-algebra class or your Algebra One class. It's the same thing. It's a squared plus b squared equals c squared. This theorem only applies for right triangles. So the theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now, the hypotenuse is the side that's across from the right angle. And it's always going to be the largest side of your triangle. So in the formula, the c squared, is the hypotenuse. The a and the b, these are the legs of the right triangle. And you can switch up the numbers that you assign for a and b. However, the c squared must always be the hypotenuse. Next slide has some common Pythagorean triples. Now, what these are numbers that you're going to see quite often on standardized tests. The most common one is the first one that's listed here, the 3, 4, 5 triangle. So if you're given a picture of a triangle, and let's say they say that this side is 3, and then they give you the length of the hypotenuse, and let's say they ask you to find that missing leg, a lot of students realize that when they see the numbers 3 and 5 on a right triangle, they automatically know that that missing side is a 4. However, if you're not comfortable memorizing these triples, you would just use a squared plus b squared equals c squared, plug in the given information, and solve whichever variable is missing. If you notice the second set of triples there, the 6, 8, 10, all they did was take the first one and times all the numbers by 2. So it's sort of like a scaled up version. That 3, 4, 5 shows up on SATs and PSATs all the time. So again, anytime that you're maybe a slow test taker, if you can recognize things like this, it does save some time where you wouldn't have to do that whole formula. And then the 5, 12, 13 is another common one, as well as an 8, 15, 17, and a 7, 24, 25. Now, these are not all the triples that exist. There are a lot more. These are just the common ones. Now, one other thing to remember is that whenever you have a right triangle, remember this biggest side, this side over here, is going to have always the biggest number. So if you had the numbers 3, 4, and 5 on a triangle, if this had 4 and this had 3, this leg could not be the 5 because it's the biggest side. So if that were the case, you would have to have done Pythagorean Theorem to find this missing side. So just remember that when you place these triples on a triangle, the biggest number must be on that hypotenuse. Everybody with me on that? Yes.
So you can switch the 4 and the 3.
Correct. You could switch the 4 and the 3, but you can't switch the 5. So you could have also labeled it like this, where you would have switched the 3 and the 4, but not the 5. The 5 must always be on the biggest side, which is the hypotenuse. Now, what I'm going to do next is I'm going to add a slide here. I'm going to do a little Algebra 1 review with you before we do example 1. I'm going to add a page. I'm going to do a little Algebra 1 review. Now, back in Algebra 1, you should have learned how to square a binomial. And actually, let me make this a minus sign. Let's do x minus 2 squared. This is a binomial. It's got 2 terms, and we're going to square it. So what this means is I can't just say do x just square the x and square the -2 and turn it into this, that would be wrong. What you need to do is write it 2 times and then either use distributive property, or some teachers may have taught you the acronym FOIL. So if you learn the acronym FOIL, what that means is you're doing the first times the first, or again, you can think of it as distributive property. We're distributing the x to the x, and then now we'll distribute the x to the -2, or in the acronym FOIL, that's the outside numbers. Then we have to distribute the -2 to the x, or that would be the inside numbers. And then finally, we would do the 2 last numbers, or distribute the -2 to the -2. And that would be our acronym FOIL. And again, these middle terms can always be combined. And then rewrite the first term, rewrite the last term. This is multiplying a binomial times itself, or squaring a binomial. We're going to be doing this on the next example. Because again, remember, our formula is a squared plus b squared equals c squared. So if b is x minus 2 and we have to square it, you need to use this FOIL or this distributive property technique. So that's a little review of Algebra 1. One other thing I want to do is, I know we did it at the beginning of the year with the distance formula, but we're going to be leaving our answers in simplest radical form. Now, if in the questions in the homework tonight, if it says to round your answer to the tenths place, then you're using your calculator. So, for example, like on the first question, you're going to get a radical answer. So let's say your answer became the square root of 75. What we need to do is leave this in simplest radical form. We did this at the beginning of the year with the distance formula. I'm going to do a factor tree. 25 times 3. Now, you can also do 15 times 5. Again, it doesn't matter what you start with. We can either recognize that 25 is a perfect square, and I could square root it and then leave the 3, or I could have also keep breaking it down until it's prime, like this one. And then I look for the pairs. Pair of 5s, 1 5 comes out, and then the 3 had no pair, so leave it under the radical. I get the same answer either way. So we're going to be leaving our answers in simplest radical form, unless the instructions in the problem, like the word problems, say to round to the tenths place. Now, one other thing you need to do is understand how to square a radical. So for example, if I want to take the square root of 5 and square it, remember this is the same thing as saying square root 5 times square root 5. That's a pair of 5s, a 5 comes out. So just remember, whenever you have a radical, and if you square it, that's really just causing the square to cancel the radical, and then the number under the radical frees up. So you don't have to necessarily go ahead and multiply 5 times 5, get 25, and then square root it. Now, if you have a number and a radical, and this is all Algebra 1 stuff, what we're going to do is, again, any number squared means to take it and write it 2 times and then multiply it. So what I would do here is multiply the 2 outside numbers together and then the 2 inside numbers. Again, I'm multiplying a radical times itself. If you want to think of this as the square root of 9 and then square root it and then now go back and multiply it, the answer here would be 12. Again, same problem. If you'd rather realize that 2 times 2 is 4, but then when you did the square root 3 times square root 3, same radical times itself, the 3 just comes out. Again, anytime you multiply a radical by itself, it frees it out of the radical. It becomes a pair, it becomes a perfect square. One other thing you need to know how to do for the homework tonight is you need to know the formula for area of a triangle. That formula is either 1/2 base times height, or you can also memorize it as base times height divide by 2. So you will need the formula for area of a triangle in the homework tonight. Yes. Okay, so let's try our first example. Now, notice in the instructions here, it says find the values of x and y. Now, I know in the formula, it's a, b, and c. You just need to realize that when you have a picture of a right triangle, the side that is across from the right angle, this is our C. Our legs are our A and our B. So a lot of times, they're not going to label the picture with the letters A, B, and C. You're going to have to pick it out and realize that the C is always at hypotenuse. So let me go ahead, and again, the formula I'm using is a squared plus b squared equals c squared. So I've decided to let the 5 be my A. I could have also said the 10 was my A. Again, the A and the B could be switched. So 5 squared plus 10 squared, and then my C is the Y. And now I'm going to square. I can't add 10 and 15. I have to square them first. Then I add them. And now I don't want y squared. I want just y. So I have to square root both sides. And this ends up giving me y is equal to the square root of 125. Now, technically, it should be plus minus, but we never want a negative side length, so we only keep the positive answer here. And now, I need to leave this in simplest radical form. So this is like question number 1 in your homework tonight. You're not using a calculator. You're leaving it in simplest radical form. So I'm going to do a factor tree for 125. I know that there are 5 quarters is $1.25. So I'm going to do 5 times 25. Now, again, if you're good and realize 25 is a perfect square, just square root it. And then this 5, it doesn't have a match or it's not a perfect square, so leave it. Now, if you prefer to keep breaking it down until it's prime, that works as well. 5 and 5 for the 25. And again, only pairs. So I have a pair of 5 comes out, and that other 5 stayed underneath. So that one stayed underneath. So the final answer here is 5 square root 5 is equal to y. Now, let me just show you another example just so you don't get confused with the homework tonight. So let's say you were trying to break down the square root of 110. So I could either divide this by 2, or I could divide it by 5, or even by 10. Let's divide it by 10. So 110 divided by 10, it's 10 times 11. Then when I break this down, I get 2 and a 5 for the 10, and then the 11. Notice no pairs could be made. So if this is your first answer for the first question, you're just going to enter it as the square root of 110. Now, if the instructions said to round to the tenths place, then you'd get out your calculator, you would hit 110, the square root button, and this answer would be 10.488088, and then rounded to the tenths, it would be 10.5. However, for the first couple questions, you're leaving it in simplest radical form. So just like this one. On the quiz, you're going to be leaving it in simplest radical form, unless it's a word problem. Let's try the next one. Here's where we're going to bring in that binomial squared. So again, the side that is across from the right angle, this is my C. Again, this could be A. This could be my B. So let's plug it into the formula. So we're going to do 5 squared plus y minus 1 squared equals y squared. I need to do that distributive property or FOIL trick for the y minus 1. So again, just to review, let's do it over here on the side. Y minus 1 squared, write it down 2 times, and we're going to do distributive property or FOIL. So y times y is y squared. Y times negative 1 is negative 1y. You don't need to put the negative 1 if you don't want to. It'll just make it a little bit easier when I go to combine my like terms. And that's a positive 1. So when I combine the middle, I get negative 2y. The most common mistake that students make, again, is they think they can just square y, square negative 1, and they think the answer is that, and they get it wrong. I can't tell you how many times at the beginning of the year with my Algebra 2 students, that's what they forget. They forget they have to FOIL. So now this is what this becomes. So 5 squared is 25. Y minus 1 squared is the y squared minus 2y plus 1 equals y squared. I now need to start combining my like terms. I can combine the 25 and the 1 because they're on the same side of the equal sign. So I'm going to get 26 plus y squared minus 2y equals y squared. I'm now going to try to group my y squareds together. So I'm going to subtract y squared. And notice when I subtract it, it actually cancels on both sides. So now I'm left with 26 minus 2y equals 0. I need to solve for y, so I'm going to add 2y to both sides. And I'm left with 26 is equal to 2y. And now I'll divide both sides by 2. And y equals 13. Now, if it asked you to find all the sides, then you would have also had to do y minus 1, which is 13 minus 1. So this side would be 12, and this one's 13. And that's one of those Pythagorean triples, those common ones. But again, if this were a quiz question, I'd expect you to do all the work because you couldn't look at it the way it was given and know that it was the 5, 12, 13. Because we don't know what y or y minus 1 were. Let's try example C. This is where we're going to be squaring a radical.
For example C, wouldn't you just know it's a 45, 45, 90?
For which one?
Example C.
Okay, so as Lori just said, C is actually a 45, 45, 90 right triangle because what we're going to learn in section 9.2 is that the length of the hypotenuse is always whatever the leg is with radical 2 behind it. Now, obviously, if you look at this picture, it doesn't look like x and 3 are the same length. So always remember, our figures are not going to be drawn to scale. So you can't go by and say, well, that one little side looks like it's the same. You can't go by what it looks like. So let's go ahead, though, and do Pythagorean theorem. She is correct. This is a 45, 45, 90, meaning that the two legs are going to be both 3 here. But let's go ahead and do our Pythagorean theorem to confirm that. So again, I can say here that this is A, this could be B, and this is always my C. It's always the side that's across from the right angle. So I'm going to go ahead and plug it in. So I'm going to do x squared plus 3 squared equals 3 square root 2 squared. So 3 squared is 9. And again, I'm going to be doing 3 square root 2 times 3 square root 2. And once I do this, 3 times 3 is 9. And then when I do the radical 2 times itself, the radical just disappears. So this becomes 18. And now I need to solve for x squared. So I'm going to subtract 9 from both sides. X squared equals 9. Square root both sides. And x equals 3. And just like Lori said, it's a 45, 45, 90. And when that occurs, both legs are always the same number. So both of these are 3's. Now again, in Algebra 2, when you're getting a question like this, x squared equals 9, technically the answer should be plus and minus 3 here. But again, we don't want a negative side of a triangle, so this is why we only keep the positive square root answer. Okay, the next example, we're reaching back to our quadrilateral chapter. So let me go ahead and draw a picture of a rectangle. Remember, a rectangle, one of its properties is that it has 4 right angles. I'm also going to draw in my diagonal. Now, it doesn't matter which diagonal I draw, because remember, the diagonals of a rectangle are congruent. So once I've drawn in one diagonal, I've now created 2 smaller right triangles. So I have that one on the bottom and then this one up here on the top. Now I'm only going to work with one of them. I'll just work with the blue one. I'm going to go ahead and label the sides that they gave me. They told me that it has a length of 8 and a width of 4. So really what I'm working with here is a right triangle, and the diagonal is my hypotenuse. So I'm looking for this C. So let's go ahead and plug it in to a squared plus b squared equals c squared. Again, the 4 could be my a, and the b could be my 8. Again, it doesn't matter. Remember, you can switch up the legs. But what's important is the C is always the hypotenuse. So I'm going to do 4 squared plus 8 squared equals C squared. 16 plus 64 equals C squared. I'm going to add 16 and 64. I get 80. And now I have to square root it. So C is equal to the square root of 80. But I need to break it down. It must be in simplest radical form. So on the quiz, technically if you did square root of 80 on your calculator, this is actually approximately equal to 8.94. So if you round to the tens place on the quiz, I'm going to mark it wrong. I want to see it in simplest radical form. Let's say you start with 8 times 10. Neither of these are prime, so I need to keep breaking it down. So 2 times 4, 2 times 5. I'm still not at prime. I still have to break down the 4. And now I look for pairs. I've got a pair of 2's. One of these 2's comes out. I can make another pair of 2's. Another 2 comes out. And then the 5 has no pair, so he stays underneath. Multiply everything that came out, so 2 times 2 is 4, and then leave the square root of 5. So the answer you would enter on Big Ideas, if it doesn't say to round, would be 4 radical 5. If it says round to the tenths place, then you enter 8.9. Now again, it doesn't matter when you're breaking down this 80, whether you did 16 times 5, which then would go right to the answer, or if you started with 8 times 10 or 2 times 40. It doesn't matter. Just keep breaking it down so that it has no more perfect squares left. Let's try a rhombus. Yes. So it says the diagonals of a rhombus have lengths 16 and 30. Find the perimeter of the rhombus. So go ahead and draw a rhombus. Remember, the sides of a rhombus are all the same. They have 4 congruent sides. Another property of a rhombus is its diagonals are perpendicular. So this tells me I have now formed 4 little right triangles inside my rhombus. I also know that since all rhombuses are parallelograms, and I know that the diagonals of a parallelogram are bisected, once I take this 16 and split it, I could say that this is 8 and this is 8. And then if I split the 30, this would be 15 and 15. Now I've got 4 little right triangles. They all have the same legs. So I need to find the length of the hypotenuse. So if I pull just one of them out, and it's got the 8 and the 15, what I'm looking for is the hypotenuse. So what I've pulled out of here, let's see if I can. I've pulled this little one out right here, this purple one, and now I'm going to use my Pythagorean theorem. So again, I'm doing a squared plus b squared equals c squared. It doesn't matter if I say 8 is the a or the b. It doesn't matter on the legs. So 8 squared plus 15 squared equals c squared. 64 plus 225 gives you 289. I now need to square root it. And this is actually a perfect square. C is equal to 17. So if when you are doing the homework, if it turns into a perfect square, you just enter that number. Now, it didn't ask me to find the side of the rhombus. It wanted perimeter. So this tells me that all 4 sides are 17. So I can now go back and just say it's 17 plus 17 plus 17 plus 17, or 17 times 4, and my answer is 68. Whether you add it up or multiply it by 4, because you have 4 of the same sides. So here, my perimeter is 68. It didn't have any kind of units on it. You could say 68 units. It doesn't really matter. I've got one more example here, and then we're done. And then I'll finish up the notes tomorrow. Pretty good? So I'm splitting the notes into 2 days. Okay, the last one, if you notice, if I look at this triangle as one large triangle first, notice the 2 x's on either side. This tells me that I have an isosceles triangle here. Then this segment that's going down the middle, and because it's got a little right angle here, this is the altitude or the height. Now, if this were a question on your homework tonight, this is where you would need to use the area question. This one's not asking for area, but again, remember the formula for area of a triangle is 1/2 base times height, or base times height divided by 2. The 6 here is the base. The 6 here is my height. So if this were the question, it would be 6 times 6 divided by 2, 36 divided by 2, and it would be 18. However, it's only asking me to find x in this question. When you have an isosceles triangle, the segment that is the altitude is also the perpendicular bisector And it's also the median of the triangle. It's actually all three of those special segments we learned about a while back. So I'm going to use the fact that this altitude is a perpendicular bisector. And I'm going to split this 6, and I'm going to say that this side is 3, and this side is 3. And now when I go to find x, I only have to work with half of the whole triangle. Because again, remember this Pythagorean theorem only works for right triangles. So if this is 6 and this is 3, this x that I'm looking for, this is really the c in my formula. So I'm going to be doing a squared plus b squared equals c squared to find x. And again, I could say that the 3 is my a and the 6 is my b. It doesn't matter. 3 squared plus 6 squared equals c squared. 9 plus 36. And actually, I should say that this is x. Let me change this variable here. Yes.
So, the scientific calculator, does that have to be a graphing calculator?
Correct, just scientific.
Okay. No graphing?
No graphing. And then now I need to simplify this. Factor tree. You could either start with 3 times 15. I'm going to do 9 times 5. 3 and 3. And then the 5. Pair of 3s. 3 comes out. 5 stays underneath. So the answer to this problem, x is equal to this 3 times the square root of 5. And this is the end of the part 1 of 9-1's notes. I will finish up the rest of the notes tomorrow. We're going to actually spend 2 days on this Pythagorean theorem.